Hello guys and gals. Welcome back to our next practice problem video. I'm going to start here on practice problem 6 and I'm not really sure how far we'll get, so we'll see. Practice problem 6 says a kinetics experiment is set up to collect the gas that's generated when a sample of chalk consisting of solid calcium carbonate is added to a solution of ethanoic acid. The rate of the reaction is determined by measuring the volume of gas generated as a function of time. Which of the following experimental conditions is most likely to increase the rate of gas production? So what they're doing here is they have a solid reactant and a liquid reactant. They're going to react them together. The product is a gas that they're going to collect. And what they've done is they've replaced concentration with volume. And you'll see this a lot with pressure as well, where they'll replace concentration with pressure. And both of those are fine. It's not going to change anything because pressure and volume are both based on concentration anyway. So if we have an increase in the volume of gas, obviously we have an increase in the concentration of gas, right? So it's working the same way. What this question is asking us, though, is what can we do to this experiment between the solid and the liquid to make it happen faster, to increase the volume of my gas faster? Well, let's take a look. A says we can decrease the volume of ethanoic acid solution used in the experiment. Well, here's the problem. Unless you're somehow magically keeping your number of moles the same when you do that, which it does not say here. It just says we're decreasing the volume. Well, decreasing the volume is also going to decrease your number of particles. And when you decrease your number of particles, you're going to decrease your number of collisions. When we decrease our number of collisions, we're going to lower the rate of the reaction, right? So if they had said in A, decrease the volume while keeping the number of moles the same, that would have been what we would want to see. Because decreasing your volume but keeping your moles the same is going to increase your concentration. We like increases in concentration because they mean more particles. They mean more reactions. But that's not what A is saying. A is just saying somebody's going to come in there and scoop out some ethanoic acid and throw it away. Well, if you're scooping out some ethanoic acid, you're taking moles of ethanoic acid with you. You're taking particles of ethanoic acid with you. And you're going to decrease your concentration. Well, not necessarily. You're going to decrease your number of particles, which is going to decrease your number of collisions, which is going to reduce your reaction rate. We definitely don't want to go with A. B, decreasing the concentration. Well, that's exactly the same thing as what we just said. If we decrease concentration, we decrease the number of collisions, we decrease reaction rate. No, not going with B. C says decrease the temperature at which the experiment is performed. Okay, well, we know heat them up, speed them up. So cool them down, slow them down. Well, slowing them down is going to make them collide less. That's not good for increasing reaction rates. That's the opposite. That's going to decrease our reaction rate. Also, decreasing the temperature is going to decrease the energy that the particles have, which means that if they get to collide, they're not going to be meeting that activation energy. All right, so C is definitely not going for it. D says decreasing the particle size of calcium carbonate by grinding it into a fine powder. So let's think. If we grind calcium carbonate into a powder, well, let's see. If we had one big block of chalk. Now we have several tiny pieces of calcium carbonate. What we're doing by grinding it into a powder is we're increasing our surface area, right? And increasing our surface area means it's more likely for collisions to occur. We have more places where collisions are capable of occurring now. And so we're going to increase our reaction rate by increasing our surface area of our reactants. So D is the best option here. Increase our surface area, increase our number of possible collisions, increase the reaction rate. So let's move on to question 7. Question 7 says you have C2H4 gas plus hydrogen gas reacting to form C2H6. Which of the following will most likely increase the rate of the reaction represented above? So this is exactly like the last question. Decreasing the temperature, we've already talked about why that is not going to increase the reaction rate. Less collisions, also less energy. That's going to decrease the reaction rate. Add a heterogeneous catalyst to the reaction system. Well, catalysts do tend to increase the reaction rate, but let's double check before we pick that one for sure. Increase the volume of the reaction vessel. Okay, let's think about this. When we increase the volume, you're giving the particles more space. The more space that gaseous particles have, the less likely they are to react. Okay, this goes back to concentration. Concentration is moles per liter, right? That's equal to molarity. So we're keeping the number of moles of gas the same here, but we're increasing our volume. Because this is on the bottom of a fraction, that means that volume and molarity are inversely related. So if we increase the volume, we're going to decrease the concentration. Decreases in concentration means less collisions, means lowering the reaction rate. We don't want to do C. Removing some hydrogen gas from the reaction system. Well, that's just a fun way of saying decreasing the concentration of hydrogen gas. It's going to do the opposite of what we want. So it looks like adding the heterogeneous catalyst to the reaction system is going to be the best choice because there's no way that adding this catalyst is going to slow it down, right? Catalysts speed it up or they don't do anything. So adding the catalyst is the best choice. Question 8. Here we have the reaction, the same reaction discussed above, but they're telling you now that they have added a platinum catalyst. That's what platinum over this arrow means. It's in the presence of a solid platinum catalyst. Factors that could affect the rate of the reaction include which of the following? Changes in the partial pressure of hydrogen. Well, if we change the pressure, that means we're changing the volume. And if we change the volume, that's going to change the concentration. And we already know that changing the concentration is going to affect the rate. So we know that 1 is an option. Changes in the particle size of the platinum catalyst. Well, the catalyst is offering another reaction route. It's going to give them a route of a reaction that is slower. So the more that they can bounce off of that catalyst, the more collisions that we have, right? So the more collisions that we have, the faster the reaction is going to go. Finally, changes in the temperature. We already know that changes in the temperature work this way. So the correct answer here is going to be E. So let's move on to question number 9. Question number 9 it's got lots of pictures. So let's take a look. 2 samples of magnesium in equal mass were placed in equal amounts of hydrochloric acid contained in 2 separate reaction vessels. Particle representations of the mixing of magnesium and hydrochloric acid in the 2 reaction vessels are shown in figure 1 and figure 2. Water molecules are not included in the particle representations. It's fine because they're not involved in the reaction. Which of the reactions will initially proceed faster? The reaction in figure 1, because the atoms of magnesium are more concentrated than those in figure 2. Well, that's not really what's happening here. What this means is that they're in one big solid piece of magnesium, while over here they're all spread out in little pieces of magnesium. So it's not that they're more concentrated, it's that they're in a bigger piece, right? The reaction in figure 1, because the magnesium in figure 1 has a larger mass doesn't really affect anything, right? And also, you don't know if all of these together could equal up to that mass or not. So I don't think that B is going to be the right answer. We'll place it on hold, but because a larger mass would mean more molecules, well, let's just place that on hold. The reaction in figure 2, because more magnesium atoms are exposed. Okay, that makes sense. More surface area means more reactions, right? More surface area means more opportunity for collisions, means more reactions. But let's check D just in case. Reaction in figure 2, because magnesium in figure 2 has less surface area. Well, that doesn't make any sense. Okay, the correct answer here is going to be C. Even though B could be correct if magnesium did have a larger mass there, the fact is having it in all one solid block is going to make this reaction happen slower no matter if you have more mass there or not, because the hydrochloric acid can't get to that mass on the inside. You can't react if you can't get to it, right? So the correct here is going to be C. More magnesium atoms are exposed. And that's the time that we have for today. I'll have to do a separate video for question 10. If it will let me stop the video. There we go.